Sketch the graph of y equals log base 9 of x plus a, where a is greater than 0 for x is greater than minus a, labelling any asymptotes and the points of intersection with the x or y axis, leaving your answers in terms of a when necessary. So let me just draw a set of axes, and then we'll talk about the approach we're going to use with this question. Right, I'm going to start off by drawing just the basic log graph. I know the basic log graph goes through the point 1 here. It has an asymptote at x equals 0, and it looks something like this. That's the basic log graph. Now, changing the base, so changing this from being a base, obviously at the moment it's base 10, if I change that to be a base 9 instead, that's not going to change the overall shape, that's just going to change the steepness ever so slightly. So I'm not going to worry too much about changing my graph here because I've not put a scale on my y-axis. So the steepness is not indicated here, and I don't need it to be indicated. What I do need to do is to take into consideration we've actually got an x plus a on the inside there. So that's going to be a transformation of this graph. The transformation, well, it's like me doing this, having a plus a on the inside of this log function. And we know that a is inside the function, so it affects the x coordinates only, and we're going to do the opposite. So we're going to subtract a from all of the x coordinates. It's going to translate the graph a squares in the negative direction. So I'm going to subtract a from this whole graph, which means first focus on the asymptote. The asymptote is going to move a squares in this direction. I don't know what a is. I know it's a positive number, so I do know it is going in this direction. But I don't know where it is exactly, so I'm going to say that that is my new asymptote. It's gone a squares that way. So x equals minus a. The question does say to label the asymptote, so I've done that. The intercept here was at 1. So I've subtracted a from that. So that's now going to be at 1 minus a. Now moving the graph back, a squares is going to look something like that. Oops. Just trying to tidy up, getting rid of the original function here. Right. So I have now drawn the graph of y equals log base 9 of x minus a. I have labelled the asymptote. I have marked the intersection with the x-axis. I haven't marked the intersection with the y-axis yet, this point here. So I do need to do that. The one thing I know at that point is this is where x equals 0. So if I were to substitute 0 into my equation here, I'll get y equals log base 9 of 0 plus a, which is just a. So this point here is log base 9 of a, whatever a is. And there we go. That is my answer for part A of this question. Right, for part B. For x is greater than minus a, describe with a reason the relationship between the graphs of y equals log base 9 of x plus a squared and y equals log base 9 of x minus a. So comparing this to the graph that I've just drawn. Now this is going to be a transformation of some kind, I can see that, because I've got the log base 9 of x plus a. The squared, though, the way that's written at the moment, that doesn't look like any of our usual transformations. Remember, our usual transformations are a times f of x plus a, f of ax, f of x plus a, f of minus x, and minus f of x. We're used to dealing with all of those transformations. The squared, not so much. But there is a trick we can use. Because it is a logarithm, and we know about laws of logarithms. So that squared, that power there, I can take that and move it to the front to get 2 log of base 9x plus a. And now I can see that this is the same graph that we had before, just times by 2. So it's a transformation like this, where we are multiplying the y coordinates by 2. Therefore, it is a stretch or enlargement parallel to the y-axis in the y direction by a scale factor 2. All of the y coordinates would get multiplied by 2. We don't need to draw this, it just says describe the relationship between the graphs. So it's an enlargement by scale factor 2 in the y direction.